Way down in the southern sky, hiding just below the giant figure of Orion, there flies a small, secret bird. This is the constellation Columba, the dove. Now, it's a group of stars that most people just completely overlook, but hiding inside its faint little outline are these incredible tales of ancient floods, of stellar exiles, and even a profound clue about our very own journey through the cosmos. All right, so here's our flight plan. First, we're going to track down this elusive bird in the sky. Then, we'll dig into how it even got its name, explore its double life in mythology, and then we meet its seriously dramatic stellar inhabitants. After that, we'll peek into its deep sky secrets, and finally, we'll discover what this little bird tells us about our own place in the universe. You know, if you live anywhere in the northern hemisphere, Columba is a true celestial ghost. It sits right south of Canis Major and Lippus, and in the winter, it just barely, and I mean barely, scrapes above the southern horizon. It's this low-flying, kind of elusive nature that makes it so easy to miss, but also so rewarding when you finally find it. Because this isn't just some faint pattern of lights up there. It's a point in the sky that connects a 16th century mapmaker's clever idea, both biblical and classical myths, and the unbelievably violent history of stars that were literally kicked out of their homes. It's a story about how we make sense of the unknown. So how does a random patch of sky get an identity? I mean, before the age of discovery, these stars were just, well, there. Ancient astronomers like Ptolemy called them amorphous, basically unformed stars near the great ship Argo Navies. They didn't belong to anything. But that all changed when explorers started heading south and mapping the unknown. And what's really cool is that we can basically pinpoint the constellation's official birthday. In 1592, a Dutch cartographer named Petrus Plancius took these leftover stars and he gave them a job. He called them Columba Noachi, Noah's dove. Just a decade later, Johann Bayer stuck it in his legendary star atlas, Uranometria, and boom, Columba was officially on the map for good. Now, Plancius wasn't just randomly drawing birds in the sky. His decision was a stroke of symbolic genius. See, right next door was the gigantic constellation Argo Navis, the ship of Jason and the Argonauts. In the 16th century, people often reinterpreted that ship as Noah's Ark. So if you've got the Ark, well, you absolutely have to have the dove, right? It completes the story. And this is just such a perfect reminder that the sky is a cultural canvas. While Europeans were looking up and seeing a bird with a message of hope from the Bible, ancient Chinese astronomers were looking at some of those same stars and seeing a family story, asterisms that represented a grandfather and a son, a symbol of the connection between generations. But here's where it gets even more interesting. Even within European culture, this little dove has a kind of split personality. It isn't just tied to one story. It actually has two major competing myths, one from the Bible and one from Greek legend. So in one story, it's Noah's dove, the ultimate symbol of hope and good news. But in the other, it's the brave little pilot for Jason and the Argonauts. They sent a dove to fly through the deadly clashing rocks. The rocks slammed shut, just clipping its tail feathers, but the ship Argo saw it and followed safely behind. So is it a messenger of peace or a daring navigator? Somehow, both stories stuck. Okay, but the myths have got nothing on the stars themselves. The real action is happening right there. Because beneath that peaceful image of a dove, Columba is home to some seriously violent astrophysics. We're talking stars spinning so fast they're about to fly apart, and other stars that are cosmic exiles on a high-speed journey across the galaxy. Let's start with Columba's brightest star, Phact. It's a perfect example of this drama. It's what astronomers call a B star. Now, the B just tells you its temperature and color. But that little E, that E stands for emission lines, and that's where the story is. It means the star is throwing off a disk of hot gas from its equator because it is spinning at an absolutely insane speed. Just try to wrap your head around that number. Phact is rotating at over 450 kilometers per second at its equator. The centrifugal force is so immense, it's flattening the star at its poles and just slinging material out into space, creating this unstable glowing disk. This star is literally spinning itself into a frenzy. But believe it or not, Phact's self-destructive spin isn't even the wildest story in Columbia, not by a long shot. That honor belongs to another star, Mu Columbae. It's a massive, hot blue giant. And here's the thing, stars like that are almost always born in big, crowded clusters with all their siblings. But Mu Columbae, it's all alone, just hurtling through space. So what happened? Well, astronomers hit rewind. They traced its path all the way back in time and uncovered this scene of absolute cosmic chaos. About 2.5 million years ago, deep inside the Orion Nebula, two pairs of binary stars got way too close to each other. It was a gravitational four-way tug-of-war, and the systems ripped each other apart, converting all that gravitational energy into pure kinetic energy. It was a slingshot on a cosmic scale. The result was pure carnage. One star, AERGA, was shot out of the cluster, heading north, and its former partner, our star, Mu Columbae, was violently ejected in the exact opposite direction, south, right into the patch of sky we now call Columba. They are stellar exiles, forever separated by that ancient catastrophe. And get this, they are still racing away from each other at a staggering relative speed of 200 kilometers per second. Even today, millions of years later, that speed is the silent, screaming testament to the incredible violence that launched them on their lonely journeys. Okay, so Columba's location in the sky actually gives us a huge advantage. It sits away from the thick, dusty plain of our Milky Way. What that does is give us this crystal clear window to look far beyond our own neighborhood. And what we see out there are the ancient relics of galactic history. Take this thing, NGC 1851. At first glance, it looks like a pretty standard globular cluster, a big, dense ball of old stars. But when astronomers looked closer, they found something really weird. It contains multiple generations of stars, which just shouldn't happen in a normal cluster. The leading theory? It's mind-blowing. This probably isn't a cluster at all. It's the stripped-down, cannibalized core of a dwarf galaxy that our Milky Way ate billions of years ago. We're looking at a galactic fossil. Another deep sky gem hiding in Columba is the galaxy NGC 1808. It's what we call a starburst galaxy, and that means pretty much exactly what it sounds like. It's going through this period of incredibly intense, rapid starbirth, way beyond what's normal. This kind of frenzy is usually kicked off by a gravitational punch from a neighbor, which in this case was probably the galaxy NGC 1792. All right, but now we get to what is, for me, the most profound role Columba plays in our sky. It's not just a collection of distant objects for us to look at. It is a fundamental signpost that tells us about our own motion right here, right now. It's our cosmic rearview mirror. To get this, we just need two quick ideas, the solar apex and the solar antapex. The solar apex is simply the direction our whole solar system is moving relative to the local stars. That direction is towards the constellation Hercules. The solar antapex is the exact opposite point, the direction we are speeding away from. And that point is right here in Columba. The best way to think about it is this. When you look at Columba, you are literally looking out the back window of our solar system's journey through space. It's the where we've just been marker in the sky. All the stars in that direction seem to be flowing away from that point, just like the scenery rushing away from the back of a moving car. And that's really the whole thing, isn't it? This one small, faint constellation seems to capture the incredible dynamism of the entire universe. It's not a static, peaceful painting. It's an arena. It's a place of immense energy, where stars are shot like cannonballs, galaxies collide and eat each other, and our own sun is on an epic journey with no end in sight. So I'll just leave you with this thought. The next clear winter night, when you glance low towards the southern horizon, what are you going to see? Just a few faint stars? Or will you see a messenger of hope, a daring pilot, a home for lonely stellar exiles, and the cosmic compass that marks the endless road our entire world has already traveled?